Hello and welcome to Beamer Folk. A quality phono preamplifier deserves a quality power supply. Ideally that would represent batteries, but they are inconvenient and it's quite nice to leave the phono preamplifier plugged into the mains. But if you choose to do it that way, there are a couple of things, in my opinion, that you don't do. One is you do not get any switching circuit anywhere near a phono preamplifier stage. It's got to be a power supply which is based on a transformer. It's got to be a mains derived, well thought through, noiseless, high immunity from left channel to right channel, analog regulator circuit. And this circuit we can see before us is my design for my phono preamplifier. It's best to start off from the left hand side here. You have an AC input here of 18.8 volts AC. Because I'm in the UK, that's 50 hertz. If you're in America, that would be 60. The first thing you encounter here is a fuse. The whole circuit of the preamplifier takes milliamps, a few tens of milliamps, no power consumption whatsoever. So if you fitted in here 150 milliamp, possibly a 250 milliamp, 20 millimeter fuse, that would be fine and dandy. The next thing you come across is just two diodes. This is not four-wave rectification, and that has significance. With the single diodes here, what I'm trying to achieve is a plus 25 and a minus 25 volts DC, derived from just two wires with 18.8 volts AC across them. And to do that, I've used just two diodes deriving the peak voltage from the RMS value. So if you multiply 18.8, allowing for the voltage drop across the diode, you've got a resistive dropper here, you arrive at a voltage here of plus 25 volts. And the same goes for if you negative rectify this in half wave, you end up via this resistive dropper into minus 25 volts. There are a couple of capacitors across these diodes, and by the way, there are smoothing capacitors here and a couple of resistors that will ensure that the capacitors get discharged when and if the power's removed. But going back to these capacitors across the diodes, well, as an AC sine wave crosses zero, it's at maximum speed, so the voltage change is its maximum. And what can happen is that the speed of that transition between positive rectification and then negative rectification can introduce into the supplies a meaningful spike. So in an audio circuit, I've learnt to put a small capacitance here, what I've got, 100 nanofarad, across each diode. Each diode actually has an intrinsic capacitance, but it's not large enough. And what that does is just take out the kick on that changeover between the two diodes. So, and I move on to the next little bit of circuitry here, and that is an LED with its dropper resistor that enables a light to indicate that there's power on, and that's taken between the plus 26 volts, 26.5 volts, through to the minus 26.5 volts. It's not connected to 0 volts here. The 0 volt is, of course, derived by the center of the two 25 volts supplies. You don't negates the need for a third terminal on a transformer. Why did I opt for that? Well, for a simple reason. I had a plug-in AC mains transformer adapter with just two wires coming out of it. If you had a plus or minus 9 volts AC. You could choose, you could opt for either running just 2 wires of 18 volts, or you could reconfigure this power supply so that you got 3 wires coming into the input. You'll notice that I've used quite high capacitors here for C3, C4, C5 and C6. These are smoothing capacitors. The reason being is that because I'm using half-wave rectification here, the frequency which is being rectified and smoothed is 50 Hertz, or indeed 60 Hertz, as compared with a bridge diode rectification circuit would produce 120 Hertz frequency ripple that needs to be smooth. So my circuit here actually needs twice as much smoothing as a 4-wave bridge rectifier circuit. But as these capacitors are quite small anyway, that doesn't really constitute a problem. I've just remembered I didn't actually do the multiple calculation for the converting the RMS to the peak. Well, if I take 18.8 volts, multiply it by 1.41 to derive the peak voltage, and that comes out at 26.5 volts DC. So at this point here, I'm getting 26.5 plus, and at that point there, I'm getting 26.5 minus. The actual load of all of this circuit does affect the supply voltage and the DC voltage. You can derive the current consumed by everything by measuring the difference between those two voltages and dividing it by R4, which is 33 ohms. Likewise, here you can do the same. This dropper resistor R4 serves 2 positive 7/8 series regulators. One goes to the left-hand channel, is that right? Yeah, left-hand channel. And the other one goes to the right-hand channel. Likewise, here in the negative, I'm using the 7/9 series, and that is the left-hand channel negative, and of course, right-hand side negative. Ignoring these two diodes for a moment, and I have to mention that I'm using the 100 milliamp, that's 0.1 of an amp, 18 volt versions of these analog regulators. Incidentally, it's quite interesting to note that actually the overhead voltage that's required for this regulator to operate in the 7/8 series, I think is about 2.5 or 3 volts. But in the 7/9 series, they use the same NPN output transistor, and so therefore it doesn't need as much. I think it only needs about a volt across them. That's why sometimes you'll see a 7/9 series regulator put in low voltage circuits because it doesn't need as great a overhead voltage. The downside, allegedly, I don't really have the technical equipment to truly prove this, but it is considered that all the 7/8 series and 7/9 series for audio work can produce on their output, and the outputs here are plus or minus 18, it can produce a little bit of electrical high frequency noise. So just to be on the safe side, what I've included is 330 microhenry. These are these very small chokes on the output with its own filter of 100 microfarad on each supply, op-amp supply. Now, going back to the diodes here. Oh, and by the way, I'm using on the output of each little 7/8, 7/9 series analog regulators, I'm using 10 microfarad capacitors as just post-regulator smoothing, and of course the 100 microfarad post-inductor smoothing. Now, the diodes. 7/8 series regulators are brilliant and have served us for many decades now, and I can't criticize them. They're quite remarkable, found in a whole myriad of circuits. But it's my experience that they suffer from one or two problems, and I don't know whether modern regulators, other than these types of regulators, suffer from this, but the 7879 series certainly do, and I've had problems caused through this. One is that if the supply on the input discharges quicker than the supply on the output, you effectively are reversing the input and output of these regulators. So you would still have voltage on the output because this charge still charged up, but you would have no charge on the input. So the output would be charged, the input would be zero. And that effectively reverse biases the regulator. And I have known them to be destroyed in doing that. And the way I've found to solve that problem is to put a diode from the output through to the input, so that the maximum differential, if this goes down to 0, is 0.6 of a volt. Because if this is high, it would make the input high minus 0.6 of a volt. So that if, say, this was at 18 volts and voltage was removed there, the input would always be, 17.4 volts. It would never fall down to 0. So as this goes down, so the input goes down, and therefore saves these regulators. Now, the D6 position, and that incidentally is true of the negatives and the positives. Now, this D6 position is interesting. What I have known and have experience of, genuinely so, is that if you have a load that loads the positive regulator down to 0 volts and the negative regulator down to 0 volts, everything is good and fine and dandy. But a problem can occur if there is a load that appears between the plus 18 and the minus 18, not attached to the 0 volts at all. And on turn on, so this circuit was completely discharged, you now plug this in, you turn on the power. On switch on, the plus 7/8 series regulator can, for a fraction of a second, is slightly faster than the 7/9, and what happens is that through that load that goes from the positive to the negative, it pulls the output of the 7/9 up to, for a fraction of a second, through to the plus 18. Doesn't seem to destroy the regulators, surprisingly, although I haven't tried it at these plus or minus 18 volts, but it's certainly true of 12 volts. That's my experience. The way to get around that is to put a reverse diode on the output, so that if this were to be faster than that, it would pull the output up, and the output through the load would attempt to pull this 7/9 up beyond 0 volts. But as soon as it gets to 0.6 of a volt beyond 0 volts, the diode here will clamp this negative output through to 0 volts. So the regulator would look as though for a fraction of a second it's just shorted to 0 volts. And then the system, the analog regulators for both plus and minus, fire up correctly. If you don't have these diodes, what you can find is a very strange situation happening where you've got the plus 18, but you've got on the minus 18, you've also got plus 18 as well. And so nothing will work properly. I've not tested this with every type of regulator, but I've certainly found that these diodes, these 4 diodes, defend the regulators from issues like that. You'll notice the diodes I've used are fairly small signal diodes. That's all you need for the L variant of the 7879, the 100 milliamps version. If you use the 1 amp version of these regulators, then I would bring these up to 1N4001, 4007, something of that order, you know, a 1.5 amp diode here, so that it can operate, do its thing safely. And that's all there is really to say about this. The output, of course, is short circuit protected via these analog regulators, and it produces a superb noise-free power supply. But I suppose nothing is quite better than batteries, but some people use batteries on Phono Preamp stages, but I've always found them a bit clumsy to deal with. This is Beamer signing out for now.